Hi and welcome back. This is part 2 of the 2016 paper 1 non-calculator paper. We'll do the last 5 or 6 questions of the paper and then you will try the questions that follow. And remember to submit your work onto Notebook for your teacher to have a look at. Number 8. Here we have an equation. We have to solve it, give the answer in its simplest form. Right, what's making this a really horrible equation is the division by 3 and the over 6, the division by 6, okay? If those weren't there, this would be a nice simple linear equation. So ideally I want to get rid of that divide by 3 and I want to get rid of the divide by 6. Now remember, when you're moving, when you want to get rid of a division by 3, you do the reverse of it, which is you multiply by 3, okay? There's actually a number that you can multiply all through by to get rid of the 3 and the 6 at the same time, okay? If you think you know how to do that, you can pause the video, have a go. I'm going to do it bit by bit, okay? Right, I've got a division by 3 and a division by 6. What I'm going to do is I'm going to multiply, to get rid of this division by 3, I'm going to multiply the whole equation through by 3. Okay, so if I multiply the whole equation through by 3, I would have 2x, the division by 3 is no longer there, take away. If I multiply through all by 3, I'd have a 15 over 6, because I've multiplied the top 5 by 3 as well. And if I've multiplied it all through by 3, the 2x would become a 6x. Okay, now I've still got a division by 6, so get rid of the division by 6 by doing what? By multiplying the whole equation by 6. If I multiply the whole equation through by 6, I would have 12x, take away 15, and remember so obviously the division by 6 is gone, so it's just a 16 there. I'm multiplying through all by 6, 36x. Okay? Let's tidy it up a wee bit. Just before I move on, you might have worked out that you could have maybe multiplied by 18 and get rid of the 3 and the 6 at the same time. Okay, if you want, if that's how you've done it, just double check, make sure you get the same answer at the end. Right, okay, so we've got an equation that's got x's on both sides. We want x's just on one side of the equation. It makes no difference which side you put your x's on, okay? I'm going to do it the most common way, which is put the x's on the left-hand side. So the 36x is going to come in here and we're going to subtract 36x. But where's the negative 15 going? That's a number on its own and I'm going to put it over here. Negative 15, move it across, it becomes a positive 15 on the right hand side. Okay? Do the subtraction, 12 take away 36 leaves me with negative 24x is equal to 15. How do I find x? I divide by negative 24. 15 divided by negative 24. Okay? Equals, it did say in its simplest form, 15, 24, a number that you can divide the 15 and the 24 both by. Divide them both by 3. 5 at the top. Divide 24 by 3. 8 at the bottom. Now you can leave it as 5 over negative 8. If you've done it yourself and you got negative 5 over 8, that's fine. Or perhaps you wrote the negative in the middle and put it as a negative and then you wrote 5 over 8 like that. All those three answers are exactly the same. Okay? Right, number 9. Here's a function, 2 over root x. It says, oops, let me wipe that off. Help if I read the question first. So it says f of x is equal to 2 over root x. Why am I writing root 5? 2 over root x. It says express f of 5. So it's got a 5 in the bracket instead of an x. Remember, this comes up as a function question sometimes. They've replaced the x inside the bracket with the number 5. So what does that mean you do? You replace the x with a number 5. So you're subbing in 5 instead of x. And that's what you've got. Now, it says write it as a fraction with a rational denominator. So we need to rationalise the denominator, that's what they're asking us. So 2 over root 5, we've done rationalise the denominator before. To get rid of the root 5 in the bottom, you multiply by root 5. And remember, the whole point of doing that is because you know root 5 times root 5 is just 5. But remember, you need to multiply the top by root 5 as well. So on the top we have 2 times root 5, 2 root 5. On the bottom, root 5 times root 5, remember, is root 25, but you know the square root of 25 is 5. That's why root 5 times root 5 is just 5. And that is it. We've done it. We've given it as a fraction. It's got a rational denominator. It doesn't have the square root on the bottom. That's us. Okay? Number 10, sketch the graph. On the sketch, show the coordinates of the turning point and show the intersection point with the y-axis. Okay, right, so the turning point comes from these values here. Okay, now that I've pointed those numbers out to you, I'm hoping that you're thinking that you know the coordinates of the turning point. Remember, it's just a sketch. You wouldn't have a squared grid or anything to do this on, so just a decent sketch. The number in the bracket is a -3. It means the turning point is +3. Okay, I don't know why that wee dots went there. It's a +3. I'll tidy it up a bit better. 3, +3 on the x-axis. Here's your x-axis here. Okay, and it's a positive one. Yeah, just remember the reason it was a -3, but we put a +3. If it was a x plus 3 in the bracket, we would have went along to -3. Okay, it's the opposite sign of the number. And then you have to go up 1 on the y-axis. So that there is the turning point. It's not too bad. It says, show clearly the coordinates of the turning point. Okay, the coordinates of my turning point are 3 along and 1 up. Okay, the diagram's not too bad. Right, what else does it ask us to show? We've also to show the point of intersection where the y-axis. Now, if you're ever asked, where does it cross the y-axis? Or you might in fact be asked, where does it cross the x-axis? There's a set thing you have to do. If it says, where does it cross the y-axis? Okay, if it mentions where does it cross the y-axis, you sub in, and I'm hoping that you're thinking, you sub in x is 0. If the question says, where does it cross the x-axis? So the other letter, the opposite way around, where does it cross the x-axis? You sub in, not x is 0, you sub in y equals 0. Okay? So the question is, where does it cross the y-axis? So we're subbing in x is 0. Okay, replace x by 0. Really what you've got there is -3 squared plus 1. -3 squared, remember, is a +9 plus 1, which is 10. The question says, show clearly where it crosses the y-axis. What was our x value? The x value was 0 and the y value was 10. So that's the coordinate 0, 10. We should show it on the diagram. My diagram's not perfect, but remember it is a sketch. Where this 0, 10 refers to is this number here is up 10. Okay? That's it. Okay. Number 11. Simplify tan squared x, cos squared x. They're stuck together side by side. Remember, they're multiplying with each other. Show you're working. Right, okay, simplify. Now, this is a trig identities type question. Right? What you need to be able to do for this question is know that tan is sine over cos. Okay, tan is sine over cos. That also means that tan squared x, oops, I'll put that wee bit under there. Tan squared x is sine squared x over cos squared x. That is a sine. Okay, so that here is what we're going to use in place of tan squared x. So the question said tan squared x, cos squared x. So instead of tan squared x, this bit here, we're going to replace the tan squared x by sine squared over cos squared. Okay, so it's going to be sine squared x over cos squared x. And remember, beside it is cos squared x, which is multiplied by cos squared x. Now, there is something you should see that should cancel out. You've got a cos squared x divided by a cos squared x. So all you're left with, because they cancel out, is sine squared x on its own. Okay? So in a trig identities question, if you see tan, replace it by sine over cos. If you see tan squared, you replace it by sine squared over cos squared. If it was a tan cubed that was in the question, you could replace that by sine cubed over cos cubed. Okay? And that was based on this trig identity here that you must know. It's not on a formula list or anything. Okay? At number 12. Let's see, the diagram below shows a rectangle and a triangle. All the measurements are in centimetres. Part 1. Find an expression for the area of the rectangle. Right, the area of a rectangle. The area of a rectangle. How do you work out the area of a rectangle? It's the length times the breadth. So, the length and the breadth, don't worry about which one is which, okay? We'll say it's x plus 8 multiplied by 2x plus 1. It's the area of this one here that we're working out, the rectangle, okay? Find an expression for the area of the rectangle. Let me just finish this one here. Now, to be honest, see if you write that down, I was just looking at the 1 mark, okay? You will get the 1 mark for it, okay? You don't actually need to multiply out the brackets just now. It's very likely that when we do part B or C, when we continue with the question, it's likely we will have to multiply out the brackets. So I'm just going to leave it like that just now. It's only worth a mark, okay? If you multiplied it all out, then that's fine, okay? But you get the mark as soon as you get to this, okay? Length times the breadth. Right. Part B. Right, given that the area of the rectangle is equal to the area of the triangle, we have to show that this quadratic exists, okay? So it says the area of the rectangle is equal to the area of the triangle. Right, so we need to work out the area of the triangle then. Let's go back and have a wee look. Right, we need to get an expression for the area of this triangle then. So area of the triangle. I'm going to do it here because we've got the picture. How do you work out the area of a triangle? The area of a triangle is half times the base times the height. Okay, so it's going to be a half times, a half times 2 bracket x plus 5 times by, running out of space, start again, a half times the base, so it's half times 2 bracket x plus 5 times by 3x, okay, that will just about fit it in. A half times 2, well, a half times 2 is just 1, okay? So really what you've got here is the x plus 5 in the bracket times by the 3x, okay? I've put the x's as a curly x, and that's a wee multiplication in them, okay? Right, so let's go back to this question. It says the area of the triangle is equal to the area of the rectangle. So we're going to write our area of a rectangle formula out. X plus 8, 2x plus 1. Right, x plus 8, bracket, 2x plus 1. That's our area of the rectangle formula. And it says it's equal to the area of the triangle. I'm going to have my area of a triangle formula, this one here. X plus 5 times 3x. Now, because it's x plus 5 times 3x, I'm just going to put my 3x at the front, okay? 3x times x plus 5, which is exactly the same as the x plus 5 times by 3x. Okay, so that's our two formulas. I've put them equal to each other. Now that looks nothing like this quadratic trinomial, right? It looks nothing like that. You'll notice on the right hand side it's equal to 0, so we really need to put everything's equal to 0. But what we really should first of all do is just let's multiply out all the brackets, okay? X times 2x, 2x squared, plus an x, plus 16x, plus 8. So that's been multiplied out the area of the rectangle formula. I'm going to multiply out this one as well. 3x times x, 3x squared, 3x times a plus 5, plus 15x. Okay, let's tidy things up a wee bit. It doesn't look anywhere near that, but we've got some x squareds and x's, so we'll tidy it up a wee bit. You'll notice the equation is equal to 0. Okay, it doesn't matter which side of the equation is equal to 0, but I will put the 0 at this side because that is what's given in the question. What I'm going to do is move everything on to the left hand side so that you're left with 0 on the right hand side, okay? So I've got 2x squared, I've got plus an x, I've got plus 16x. I'll tidy it all up in a wee minute. We've taken away the 3x squareds and we're going to take away the 15x as well. Let's tidy it a wee bit. 2x squareds take away 3x squareds leaves you with negative 1x squared. Plus x, plus 16x, that's 17x. Take away 15x. 17, take away 15, it leaves me with plus 2x. And we've got a plus 8 in the middle. There we are. Now you'll notice it kind of looks a bit like that, but not quite. There's a very, very simple thing we can do to change all the signs in this equation. Right, just flip it all round. Okay, move everything on. Negative x squared, move it over, minus 2x, minus 8. And that is the equation that we were asked to show. Okay. Right, let's see. Part, oh, there is a part C. Hence means now use your answer you've just worked out. Find the length and the breadth of the rectangle. Right, let me just use the equation that we've got. X squared minus 2x minus 8 equals 0. Let me write that down. X squared minus 2x minus 8 equals 0. It's saying find the length and the breadth of the rectangle. Basically, find x. Okay, that's what we're going to work out. Find x, and this should hopefully allow us to work out the length and the breadth of the rectangle. Find x. Right, how do you find x? How do you solve this? We're factorising. Set it equal to 0. Two numbers that multiply to negative 8 that add up to negative 2. Two numbers that multiply to negative 8. Let's rethink. Negative 4 times 2. They multiply to negative 8. Do they add up to negative 2? Yes, they do. X minus 4, x plus 2. What are the solutions? How do you get the solutions? You take each of the factors and set them equal to 0. Move the minus 4 across, add it on the other side, remember? X is 4. And the other factor, set equal to 0 to get the solutions. Move the plus 4 across and take it away. 0 take away 2. So we've got two solutions. Either x is 4 or x is negative 2. Now let's go back and check what x actually is, because it might be the case that x can't be negative. Right, yep, x plus 8 is the length of the rectangle. See if that x was negative 2. No, let me have a wee look. X is negative 2. X is negative 2. Yeah, but this one here. See if x was negative 2 there. 2 negative 2s is negative 4, add 1. It means the breadth of that rectangle would be negative. Quite often this is what happens at the end of your quadratic question, okay? Quite often you eliminate the negative answer because it doesn't actually make sense. If x was negative, this wee bit here, if x was negative 2, 2 negative 2s is negative 4, add 1. It just doesn't work, right? You can have a length that's negative. So this is our answer here. for x. This is our value of x. That is or not our value of x. So the question says, what's the length and breadth of the rectangle? Right, let's go back. What's the length? The length was x plus 8. Right, that's our measurements here. X plus 8 and 2x plus 1. Doesn't matter which is the length, which is the breadth. So x plus 8, x is 4. 4 plus 8, so it's 12. And I did say it was in centimetres. Our other measurement was a 2x plus 1. 2x plus 1. X is 4, so it's 2 fours. Add 1, which is 9. So that's our length and breadth. Okay, I don't think there's another question. I'll let me go on and have another wee look. No, that's us. Okay, so I'm going to set you a few questions similar to these ones here. I know some of them are quite tricky, this end of the paper, okay? Try your best and let me know if you need any help. Right, good luck, bye-bye.